Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. Solve for the first column, x, y, and the second column, t, z, of A inverse, for A equals the 2x2 matrix with entries 10, 20, 20, 50. By solving the two systems A times x, y equals 1, 0, and A times t, 0. The identity matrix is built from the target vectors E1 and E2. Each column of A inverse is the vector that A sends to the corresponding column of the identity. Let's write the matrix equation as two equations in x and y. The solution, x, y, is the point where these two lines intersect. We scale the first equation, so the x coefficients match. Subtraction eliminates x completely. So y equals -1/5. Plug y into the first equation to finish solving for x. This solution becomes the first column of A inverse. Now we solve the second system to get the second column of the inverse. The point, T, Z, is where these two lines meet. The first equation directly gives T as a multiple of Z. Substitute into the second equation to solve for Z. That simplifies to a single equation, giving Z equals 1/10. Then T equals -1/5. This is the second column of A inverse. Put the two solution vectors side by side as columns. That's the inverse matrix. Let's verify column 1. Each row is a dot product, and it really lands on E1. And column 2 lands exactly on E2. The inverse is built column by column by asking, which vectors does A send to E1 and E2? Those two solved vectors are the entire story. Assemble them into the inverse matrix. If you liked this solve for the columns approach, you're going to love what comes next. Hit play and keep the momentum going.